welcome back to our channel. Okay, good morning to all. Today we are discussing about the heat part 3. Heat part 3. In previous class we discussed about the what is specific heat, units of specific heat. After that, methods of mixers we discussed about it. What is methods of mixer? Net heat lost by a body is equal to net heat gained by a body. It is the principles of methods of mixers. Today we are discussing the very important lab activity. In previous examination, so many times asking that question. So everyone listen carefully. Okay. So first of all, activity means what you know that aim, material required, procedure and result. Okay, these four are commonly we write. So first we write aim. What is aim? Aim means to find the specific heat. To find the specific heat of a given solid. Experimentally. What is aim? To find the specific heat of a given solid experimentally. To find the specific heat of a given solid experimentally. After that, second one is the material required. Material required or material apparatus. Which materials we do this activity we are using? Here using that material required is calorimeter, thermometer, stirrer, water, wooden box, steam heater, steam and lead shots. These are the materials required: calorimeter, thermometer, stirrer, water, wooden box, steam heater, steam and lead shots. These are the material required. After that, procedure. Take a calorimeter or measure the calorimeter. Along with stirrer. Measure the calorimeter along with stirrer. Its mass is m1. Measure the calorimeter along with stirrer. Its mass is m1. So actually calorimeter ila undanukunnam. Calorimeter. This side we are using the cotton. In between gaps we are using. Why the cotton are using? If there is no heat transfer to the outside or surroundings. So here using that, it is the one of the calorimeter and it is the stirrer. Next, second one. Now fill 1/3 volume of water into the calorimeter. Now fill 1/3 volume of water into the calorimeter. Its mass is m2. It is a calorimeter. This one filled with how much amount of 1/3 volume of water into the calorimeter. Next, mass of the water is before filling the water, the mass is m1, and after filling the water mass is m2. So what is the difference? Mass of the water is m2 minus m1. Before filling the water m1, after filling the water m2. So mass of the water is m2 minus m1. At this time, calorimeter and water have same temperature. Okay na? This same temperature, its temperature is T1. Its temperature is T1. So it is the first measure the calorimeter along with stirrer. Its mass is m1. Now fill 1/3 volume of water into this. Its mass is m2. What is the mass of water is m2 minus m1. This situation, calorimeter and water both are having same temperature. Its temperature is T1. Next, take lead shots. It is kept in steam heater. Take lead shots. It is kept in steam heater. Heat up to 100 degrees Celsius. Its temperature is T2. After that, take a lead shots. It is kept in steam heater. Heat up to 100 degrees Celsius. Its temperature is T2. Now lead shots quickly transferred into the calorimeter. Now lead shots quickly transferred into the calorimeter. Why quickly transferred? If there is no heat lost, that's why it is now lead shots quickly transferred into the calorimeter. Okay, calorimeter along with contents is M3. What is calorimeter along with contents means? What here have? Calorimeter, water, and it filled that lead shots. Here small black color circles have the lead shots. There is no heat transfer to the surroundings. So here one draw the thermometer. It is the M3. Next, mass of the lead shots is M3 minus M2. Mass of the lead shots is M3 minus M2. Next, now lead shots quickly transferred into the calorimeter along with contents is M3. Mass of the lead shots is M3 minus M2. Now lead shots resultant temperature is T3. What is resultant temperature means? You already know that water and calorimeter both are having same temperature. Its temperature is T1. After that, lead shots is 100. It is the hotter body and it is the colder body. When both are mixed, hotter body heat lost and colder body heat gained. So this resultant temperature is in between T1 and T2. So it is T3. This is the resultant temperature. After that, now lead shots. Temperature lost by a lead shot is temperature. How much amount of before in steam have the T2 and when it is kept in water it have the T3. So heat lost is T2 minus T3. T2 is the maximum temperature and T3 is the minimum temperature. So heat lost, hotter body to colder body. After that, temperature gained by a calorimeter plus water is T3 minus T1. T3 minus T1. You understand this? If the specific heat of values of calorimeter, water and lead shots is calorimeter. Already you know that specific heat is showing S. So calorimeter says SC. After that, specific heat of water, so SW, and specific heat of lead shots SL respectively. Next, according to method of mixer, net heat lost by a lead shots or solid is equal to net heat gained by a calorimeter plus water. It is the Net heat lost by a solid is equal to net heat gained by a calorimeter plus water. How much amount of heat will be lost? Solid. Already I am saying the formula in previous class. Q is equal to ms delta T. Here we using this formula. Q equal to ms delta T again. Net heat lost by a solid. Which is the solid here using? Lead shards. So lead shards, M says mass. Mass of the lead shards is mass. Lead shards mass is M3 minus M2. M3 minus M2 is the lead shards mass. After that, lead shards specific heat is SL. And lead shards temperature, lead shards heat lost or heat gained? Temperature lost by lead shards is T2 minus T3. This is the lead shards is equal to net heat gained by a calorimeter. First again we take the formula of mass. Mass of the calorimeter is M1. Next mass specific heat of calorimeter is SC. Next heat gained by a temperature gained by a temperature gained by a calorimeter is T3 minus T1. It is the calorimeter. After that, here given that plus water. Next, mass of water. What is the mass of water? M2 minus M1. M2 minus M1. M2 minus M1. Next, specific heat of water SW. After that, delta T. Delta T says again T3 minus T1. So that implies M3 minus M2 into SL into T2 minus T3 is equal to, we take common T3 minus T1, we take common, so M1SC plus M2 minus M1 of SW into T3 minus T1. After that, we are given that formula SL. SL is equal to M1SC plus M2 minus M1 into SW into T3 minus T1. These terms take that side. So M3 minus M2 into T2 minus T3. It is the formula of specific heat of a given solid experimentally. Again listen carefully. It is a very important question. Okay. So aim. What is aim? To find the specific heat of a given solid experimentally. It is the aim. After that, material required. Which material here using? Calorimeter, thermometer, stirrer, water, wooden box, steam heater, steam and lead shards. These are the material required. After that procedure, what is the procedure we are using? Measure the calorimeter along with stirrer. First measure the calorimeter along with the stirrer. Why we are using the stirrer? In calorimeter, any impurities have, it is left for using the stirrer. After that, its mass is M1. Now fill 1/3 volume of water, into the calorimeter. So before filling the water M1, after filling the water M2. After that, what am I here asking? Mass of the water is M2 minus M1. At this time, calorimeter and water both are having the same temperature. Its temperature value is T1. This is the next. Now take a lead shards. It is kept in steam heater. Heat up to 100 degrees Celsius. The lead shards is heat up to or heat rise to 100 degrees Celsius. That temperature is T2. After 100 degrees Celsius absorbing of heat, the lead shards, it is quickly transferred into the calorimeter. calorimeter. So calorimeter, it's along with contents is M3. Again, mass will be increase or decrease? Increase. So mass of the lead shorts is M3 minus M2. Before filling the, now lead shorts quickly transferred into the calorimeter along with contents is M3. So mass of the lead shorts is M3 minus M2. After that, now lead shorts resultant temperature. What is resultant temperature? Before temperature is the low temperature. Water temperature is T1. It is the lead shorts temperature is T2. T2 is the 100 degrees Celsius temperature. So it is the maximum temperature and it is the minimum temperature T1. When both are mixing, so the resultant temperature is T3. So resultant temperature in between T1 and T2. It is the maximum or high temperature and it is the low temperature. So resultant temperature is T3. After that, the temperature lost by a lead shorts is how much amount of heat lost? First temperature is T2 and result temperature is T3. So T2 is maximum than T3. So T2 minus T3. It is the temperature lost by a lead shorts. But temperature gained by a calorimeter plus water is, it is T1, T3 minus T1. T3 is the resultant temperature is maximum than initial temperature of T1. So T3 minus T1. If the specific heat values of calorimeter, water and lead shorts is specific heat values. Already you know that specific heat is denoted by letter S. So yes, calorimeter is SC, water SW and lead shorts SL respectively. According to methods of mixer, net heat lost by a solid is equal to net heat gained by a calorimeter plus water. Here, heat lost body is the lead shorts. Heat gained by a body is calorimeter and water. So, we take the formula Q is equal to ms delta T. Q equal to ms delta T. So, first write that heat lost by a lead shorts. Lead shorts mass is, what is the mass? Lead shorts mass is M3 minus M2. So in place of M we write M3 minus M2 into specific heat of lead shorts is SL and heat lost, temperature lost T2 minus T3. So these are the Q is equal to ms delta T, we using that formula, is equal to M1 SC. M1 is equal to net heat gained by a calorimeter. Calorimeter mass is M1. Calorimeter specific heat is SC. And calorimeter gained by a temperature. Calorimeter and water both are gained T3 minus T1. So again this one also substitute this formula. This formula we are using that M1 SC into T3 minus T1 plus. Next water. The mass of water is M2 minus M1 into specific heat of water is SW and temperature gained by a water is T3 minus T1. So M3 minus M2 SL T2 minus T3 is equal to M1 SC plus M2 minus M1 SW into, we take common of T3 minus T1. Then SL is equal to M1 SC plus M2 minus M1 SW into T2 minus T1 by M3 minus M2 and into T2 minus T3, take this side. So specific heat of a given solid experimentally SL is equal to M1 SC plus M2 minus M1 SW into T3 minus T1 by M2 minus M2 into T2 minus T3. So by using this formula to find the specific heat of a given solid experimentally. Okay. So it is a very important question. So everyone learn. After that, tomorrow we'll discuss about the heat part 4. Tomorrow we'll discuss about the heat part 4. So who are watching my first watching my videos, please subscribe. Okay. Bye Nana.